Hello and welcome to today's webinar. Today we're going to cover the exciting new features in nRF Connect SDK version 2.8.0 and version 2.9.0. So we had to, decided to do a combined webinar as unfortunately we had to cancel the webinar for 2.8.0. So we're going to cover those features as well as the ones from the latest one, which was 2.9 that we released just before Christmas time last year. So I'm your host for today. My name is Tiag Mont. I'm a developer marketing manager here at Nordic Semiconductor. So one of our pillars at Nordic is to excite and support developers. There's various ways that we use to interact with developers out there. So we have the webinars, like the one that we are hosting right now. DevZone, this is where our tech support team hangs out, as well as other members of the Nordic community that also give support to each other. So which is really, really great to watch. Then we have Tech Talks. This is our single source for all technical documentation across hardware, software, cloud, everything, tools. And last but not least is the Dev Academy. So this is our interactive online learning platform where you can get our courses on the nRF Connect SDK, Bluetooth, Wi-Fi, and cellular IoT with hands-on practical exercises as well. The agenda for today, we'll start with some generic updates and tools, which will include a demo, just showing you how to get started with the nRF54L15DK. Then we'll have some updates on Bluetooth, also including a demo on Bluetooth LE subrating. Matter and Thread updates, again with a demo on Matter, one of the new features in Matter 1.4. Updates on Wi-Fi, and we'll wrap up with updates on Cellular and Cloud, and then we'll move on to the Q&A to close out the webinar. Okay, so let's get started with the generic updates and tools for nRF Connect SDK 2.8.0 and 2.9.0. So the first thing, the start of the show, is that we have now support for nRF54L series that was launched in mid-November last year. It feels like a long time ago, but it really wasn't. So in the nRF Connect SDK 2.8, so that was the first release that brought support for the nRF54L15DK and the nRF54L15 SoC. And then on the nRF Connect SDK 2.9, we extended support for the nRF54L10 and L05 SoC. So we actually launched 3 devices in the nRF54L series, and the nRF54L15DK can be used to emulate the 54L10 and 54L05 SoC. So you don't need, we don't have sort of dedicated kits for those 2 devices. They can just be emulated with an emulated target when you select the build configuration. If you want to learn more about the nRF54L15, we also had a webinar in early December, so I strongly recommend that you go in and watch that. And this is what the kit looks like. So you have your USB connector here, power switch, the onboard debugger button, so it's a very familiar form factor, or at least functionality, than the kits that you know from Nordic. So what are you getting in terms of support on the nRF54L series? So all the standard SoC peripherals are supported. Also, device firmware update, DFU, is supported. This is provided by the single-stage immutable bootloader in MCU boot. Also, PSA crypto APIs with hardware acceleration are supported for any cryptographic operation needs that you might have, also for key storage. There is also support for the NPM 1300 PMIC. So a lot of applications, especially battery-powered applications, will require an external PMIC. So I recommend it to take a look at the NPM 1300 that not only provides you with power management capabilities, but also battery charging and also fuel gauging. And then when it comes to wireless protocol support, so going from the, let's say the smallest part here with the least amount of RAM and non-volatile memory. So the nRF54L05 supports Bluetooth LE, Bluetooth Mesh, Thread 1.4 and 2.4 gigahertz proprietary. Then the L10, so supports everything that the L05 supports, and in addition also Amazon Sidewalk and Matter over Thread. And then the L15, the largest device in the series so far, supports everything above, plus Find My Device, Find My Network, so from Google and Apple respectively, their ecosystems, and also support for Wi-Fi at experimental stage. This means that you can use the nRF54L15 as a host to a nRF70 series Wi-Fi 6 companion IC from Nordic. And just a reminder that to get access to the Find My Network extension, you need to be a member of the Apple MFI program, Apple Find My. Also on the tools, so the board configurator in nRF Connect for Desktop supports the nRF54L15DK. So you can control the VCOMs, whether you want the debugger enabled or not through that, and also what is the power level that you want to apply. And also in the quick start. So the quick start also supports nRF54L15. So this is a great way to get started. And yeah, so I'm actually going to show you now a demo of how you can easily flash an application and test it also on the nRF54L15DK. So let's move on to the demo and then we'll continue with the webinar. Okay, so let's get started with our demo. So I have the nRF54L15DK connected to my computer. And then I have the nRF Connect for Desktop application. I'm going to use the Quick Start application inside nRF Connect for Desktop. And I have a mobile phone that I'm going to use to interact with the kit after we flash one of the pre-compiled samples. So I'll just go ahead and open the Quick Start. And as soon as you open Quick Start, it will start searching for a Nordic kit connected to the PC. The kit is not powered on, so it will say that this is taking longer than expected. So I'll just go ahead and flip the power switch over there, and it will immediately recognize that there's a kit connected, and it will take us through the quick start step. So first you get sort of an overview of the kit that is connected to your computer. If you have multiple kits, you can select that before the step, so worry not, it will not make that selection on your behalf, let's say. So we'll continue here. You can give your kit a custom name. I've already done that. The nice thing about this is that you will see whatever custom name you give it, you'll see that across all the applications in nRF Connect for Desktop, as well as nRF Connect for VS Code. So it gives you a really easy way to identify the kit that you're interacting with, especially if you have multiple kits, multiple of the same type of kit, you can give them a unique name. So it's much easier. I'm going to skip this. Then you have a list of applications that you can program: Hello World, Peripheral LED Button Service, and Peripheral UART. If you want to know more about these applications, you can just click on the link there and it will take you to the documentation for the sample. I'm going to flash Peripheral LED Button Service and I'm going to program, and you will see that the debug interface LED will start blinking, indicating that we are flashing the device, and it was really quick. So it's already done. We can continue with the next steps. Then we have sort of a small terminal emulator just to see the boot message that's coming from the firmware to verify that the flashing has been successful, which is the case here as well. So we'll continue to the next step. Evaluate Peripheral LED Button Service. So it takes you to the part of the documentation, in this case the sample documentation with the testing steps. It instructs to use the nRF Connect for a mobile application. I'm going to use nRF Blinky just because it's a simpler application to interact with. So I'm going to use that one instead of this one. But if you would follow these instructions, you would be able to essentially accomplish the same things and toggle the LEDs and get the button press notifications on your phone. So we'll continue here. Then recommended learning resources. We've already discussed a few minutes ago about the Developer Academy, Zephyr videos, and the videos for VS Code and so on. And you get also some links to very useful recommended pieces in documentation that tell you how to develop with the nRF54L series device. So we'll continue here. Then you can install VS Code IDE and command line utilities if you don't have them. So if this is the first time you're getting started, you don't have a Nordic environment yet, this will be very useful to accelerate sort of getting that first initial installation in place. So I already have that, so I'm going to skip. Then you can install recommended applications in nRF Connect for Desktop, which I already have installed. So there's nothing for me to do here. But again, if it's the first time, this would be an easy way to get those installed as well. I'll just continue, and we're done. We have our application flashed and running, and then we can use the mobile phone and interact with the kit. So I'm going to close this. So the first thing I would like to highlight is that there's an LED blinking. So this is just, so we know that the firmware is running. And then I'm going to pick up my mobile phone and open that. Here we go. And I'm going to open nRF blinking. So it will start scanning and it will immediately recognize the kit, which is advertising. And you'll see that when I connect, so let me actually use my mouse cursor to interact with the application. So when I choose this device and I connect to it, we'll see that LED 1, so this is LED 0, the one that is blinking, then LED 1 will turn on when we connect. So this indicates that we are connected now. And now we can do two things. We can control one of the LEDs, which will be LED 3, this one over there, and we can get the button press notifications. So if I now toggle this, you'll see that that LED has turned on, it will turn off. And if I press, I believe it's button 0, we will see the button state changing on, off. Again, if I press on, off. So it's really, really easy to get started with nRF54L15DK together with Quick Start. This is just one of the multiple applications you can try. And then from there, really recommend check out Developer Academy and get started with development. So you can go ahead and develop your own applications based on these devices. Okay, so that was our demo of the nRF54L15 Quick Start and unboxing. And let's continue now with the rest of the webinar. Yeah, so that's how easy it is to get started. Just grab yourself a kit and start developing. And to help you with that, there's a couple of YouTube playlists I would like to highlight. On the left-hand side, we have the nRF Connect for VS Code tutorials. So a series of videos that show you how you can get started with the nRF Connect for VS Code extension. And then a more recent one is a series of hands-on videos on nRF Connect SDK. So this shows you how you can go, starting with the rapid prototyping and going through different steps. So adding sensors, sending and receiving data through your Bluetooth LE link, storing data, power optimizations using the Power Profiler Kit 2, and lastly, adding firmware over-the-air support, so you can update your device through a mobile application. So I really recommend that you go and check these out. And to move you further in your development journey, we have the Developer Academy. So now the Bluetooth LE learning path. So all these 3 courses highlighted in the middle, the nRF Connect SDK Fundamentals, Bluetooth LE Fundamentals, and nRF Connect SDK Intermediate, they all have support for nRF54L. So if you grab yourselves the nRF54L15DK, you can go ahead and go through these courses and sort of deepen that knowledge and streamline your development process with our educational materials. Okay, so moving away from nRF54L15 into a little bit different topics. Something else that was added on nRF Connect SDK 2.8 was MCU image compression. So this is experimental level. So what does this mean is that using LZMA2 algorithm, you can compress the candidate image. So basically the image that goes to the DFU slot by about 30%. So this means this gives you more space, right, for your application needs. So this means that you can, when you need less space for your DFU slot, you can grow your application to take that space that was left unoccupied, but you might also want to use that for storage. So it's really up to what you need in your application, how you want to use, how do you want to make use of that additional space. So this 30% is an approximate number. It can vary for larger applications. For example, for Matter applications that are a little bit larger, you might see an increased compression rate, and for smaller applications it might be a little bit smaller compression rate. So this is just an indicative number, and this is supported on the nRF 52840, nRF 5340, and nRF 54L15 targets. We have recently published a DevZone blog that goes a bit deeper into this with an actual practical example of how you can implement the image compression on a Bluetooth LE image and then send that over a mobile phone and DFU that compressed image into your target. Okay, on nRF Connect for VS Code, one important change that's really worth highlighting is that now the SDK and the toolchain selection, they are now specific to each build configuration. So why this is important is that this is a change in behavior compared to what we had before. So before, the SDK and the toolchain selection would apply to all the projects in the workspace. So if you had a VS Code workspace and you had, say, 5 projects in there, the SDK and the toolchain selection would be sort of a global selection. So once you would go and change that, all of your projects would build against that SDK and toolchain. Now you can do that on a build specific configuration. So if you have 5 projects, each project and each build under each project can have its own SDK and toolchain selection. So even the same project with multiple builds can have a different SDK selection there. So this gives you a lot more flexibility because you're not tied to this global selection on the SDK, and you can just do it at the project, well, actually at the build level. So it's it's a lot more flexible if you're working with multiple SDK versions across multiple projects. Then a few small updates on Sidewalk and Zigbee. So on the Sidewalk, the version was bumped now to 1.17. That's supported on nRF 52840, nRF 5340, and nRF 54L15 devices. So this brings some improvements. You can read more on Amazon's Sidewalk website, but in metrics, so ability to get more telemetry and capability reporting, and it also enables an endpoint to limit the uplink traffic. So if you want to sort of put a cap on how much traffic is sent through Sidewalk, you can use that feature. Another thing worth highlighting is that Zigbee release 22, this is now deprecated in the SDK. This will be removed no earlier than after the next 2 releases. So actually this was in 2.8, which means that it will be removed no earlier than the next release after 2.9. And this is following our deprecation policy. As a result of this deprecation, the nRF 52833, 52840, and nRF 5340 devices, these are not recommended for new Zigbee designs. However, we did introduce support for Zigbee R23. This is available for the nRF 54L series only, and this is an add-on on the nRF Connect SDK. And so you might be asking the question, what's an add-on? What's an nRF Connect SDK add-on? So let's get to that and answer that question. You might have already seen this if you're working with nRF Connect for VS Code, but add-ons are essentially an extension, a way to extend the functionality in the SDK. So both Nordic as well as third parties can provide additional components, additional functionality. So this can be just applications, that can be samples, that can be libraries, that can be entire protocols, like in the case Zigbee, and more things. So there's a lot of flexibility. They can be authored by both Nordic as well as third-party vendors. And the key thing between add-ons, so they're not part of the SDK, they're outside the SDK, right? But you can build them, like if they're samples, you would build them as if you would build SDK samples. But the key thing is that they have an independent release cycle from the nRF Connect SDK. So depending on the add-on, they might be aligned. So they might be, updated to the latest release shortly after there's been a new release. But the author might also choose to support only selected versions or selected releases of nRF Connect SDK. So that will be indicated on the add-on itself, like which versions of nRF Connect SDK the add-on is compatible with. They are fully integrated with nRF Connect for VS Code, and I'll show you that on the next slide. And you can also browse these separately on the gallery. So there's a link here. And if you go to Tech Docs, scroll down a little bit, you'll find sort of a tile that takes you directly to that page. But let's first have a look at nRF Connect for VS Code integration. So when you go to the Create New Application flow, you have these 3 options. And that's why I said that you might have seen this before. So the first one is create a blank application. Copy a sample, which is probably the most common way that a lot of developers get started. And then you might have seen this, browse nRF Connect SDK add-on index. So this then takes you to the list of add-ons that you currently have available. And if you click on that, then you will see that list. So like I mentioned, that this can come from both Nordic as well as third parties. So right at the top, we have the factory firmware for the ThingEX prototyping platform that we'll actually discuss in the webinar today. Zigbee, as it was just mentioned, so you can have that through an add-on. But then we have companies like BLEcon, Semtech with a LoRa application using their transceivers. Onomondo, one of our partners on the cellular side of things, supplying SoftSim implementation. Connexio, Goliath, so there's many here. So this is how you get access to the add-ons through nRF Connect for VS Code. But if you just want to browse and see what's available, you can go to that page linked on the slide, and you will see the the list here. So it's the same list as you can see here, Thingy 91X at the top, Zigbee, and so on. So these are the two ways of doing that. Okay, so let's continue to the next topic. So moving on to Bluetooth updates, starting with Bluetooth LE audio. So in nRF Connect SDK 2.8, we added as experimental a new sample called nRF Aura Config. Aura Config is name derived from Auracast. So this implements the broadcast asynchronous stream, shortened as BIS. So it's a BIS gateway mode for the nRF 5340 audio applications, which are a separate set of applications in the SDK. So it can essentially act as an Auracast broadcaster if you're using presets that are compatible with Auracast. And you can set up other nRF 5340 audio kits to synchronize those broadcasts. So you have a shell interface, and that's how you can configure this broadcast source in different ways. So this sample has some limitation. It's meant to be used with a maximum of 2 broadcast asynchronous groups. So this is how you sort of synchronize, for example, left and right in stereo broadcast for earbuds, and each of those with 4 broadcast asynchronous streams each. Then on Bluetooth LE, experimental additions to the SDK. In the nRF Connect SDK 2.8, we added channel sounding as experimental. So channel sounding will only be supported in the nRF54 devices, so both the L and the H. So in this case, it was added for nRF54L series device, which is the one that we launched. So channel sounding, in a nutshell, if it's the first time that you heard about this, this enables accurate and secure distance measuring. And one of the key things is that it has security built in. It also it will be interoperable, so you can have distance measurement between devices regardless of the Bluetooth vendor, and this will hopefully also be expanded to mobile phones. And then on 2.9, we added on top of that, also as experimental, 2 samples: the channel sounding reflector with ranging responder and channel sounding initiator with ranging requester. So these 2 samples show you how you can use the ranging service between these 2 devices. So basically, they will connect to each other, and they are mostly meant to demonstrate data flow between initiator and reflector. These are the technical terms between 2 devices that use channel sounding to measure the distance between each other. One really important thing is that in these samples, the ranging algorithm is only there for illustrative purposes. So you will see a distance calculation coming out of the serial port, but that is just for illustrative purposes, which means that the algorithm is not optimized yet, and the accuracy that you'll see there is not representative of what you will be able to achieve with channel sounding when we have a algorithm that is tested and verified to do accurate distance measurement. So just wanted to highlight that. Yeah, you can learn more about channel sounding on nordicsemi.com if you go to the Bluetooth LE landing page, but this link will take you directly there as well. And then we have some supported features in nRF Connect 2.8. LE power control, so that was introduced back in 2.2, so it's been a while. That was introduced as experimental, and now it is supported. If it's the first time you've heard about LE power control, so what this gives you is that it allows 2 devices to sort of automatically adjust the signal strength between devices. So which means that when devices go further apart, they could increase the signal, the TX power, and when they get closer to each other, they can decrease the TX power. So it can enhance both the connection reliability. So you don't have, if you're moving away, you increase the TX power to make sure that you don't drop data, but also power efficiency. So if you come closer together, you don't need such high TX power, and then you can adjust the signal strength so that you save battery and you don't use so much energy to transmit data. Another thing that was added was connection subrating. That was introduced in nRF Connect SDK 2.7 as experimental, so this is now supported. So this offers a more flexible way to change between high and low duty cycle connection. So the way you do that is with changing connection parameters, but that can take time in changing the connection parameters. And now you can do that in a much faster way. And we have a couple of slides dedicated to this and also a demo in a few minutes. And that there's a sample associated with that feature that can be used to showcase it, called Bluetooth connection subrating. And then on 2.9, we also added a new feature, which is parallel scanning and initiating connection. So this helps because when you are scanning and connecting, especially if you're trying to connect to multiple devices, it could take a while. So this now reduces this waiting time overall, basically, when you're trying to discover several Bluetooth devices and connect to them at the same time. And there's also, so this link takes you to the sample that showcases that feature. Yeah, so okay, so like I mentioned, going a bit deeper into this Bluetooth LE connection subrating. So what this gives you is that it's an enhanced way of making applications that are more energy efficient as well as more responsive. This feature was introduced back in Bluetooth 5.3 5.3 specification, and it allows you to really quickly switch between a low and a high duty cycle connection without changing the connection parameters. And why is that important? So essentially, in any wireless device, if you want to save power, the formula is very simple. Just don't use the radio, right? Which sounds counterintuitive. It's a wireless application. You need to use the radio. But the least you use the radio, the better. But when you do that, you also lose responsiveness, right? So that means that if you're in a mode where you want low power, you use the radio less. If you're in a mode where you want low latency, you use the radio more. The challenge with changing connection parameters to go from low power to low latency mode is that changing the connection parameters in itself also takes multiple connection intervals, right? So let's say that you're, for example, in a 1 second connection interval, and you're sampling a sensor, and all of a sudden your sensor goes above a certain threshold where you want to send data more quickly, right? You want to sample it faster, you want to get the data faster as well. Let's say you want to switch from 1 second down to 10 milliseconds, for example. Just switching the connection parameters can take, from the top of my head, I think it's up to 6 connection intervals. So it would take 6 seconds before you would go from 1 second connection interval to 10 millisecond connection interval, which might not be acceptable by a lot of applications. So with this feature, you don't have to wait that long. Well, you don't have to wait at all, to be honest. You just switch straight away. So you'd go from a low power mode to a low latency mode straight away. And if you want to go deeper into how this works, I've put a link here to the Bluetooth 5.3 technical overview document from the Bluetooth SIG. And if you hop to section 3.2.3.1, you'll have all the details. But to save you some time, I can explain this a little bit, briefly using some of the images from that technical overview. So the way that the subrating works is that it uses something called subrate factor and continuation number. So what is this subrate factor? So the subrate factor it basically indicates which connection events will actually be effective connection events used by both the central and the peripheral. So in this example here, let's say that the connection interval would be the one highlighted, and every of these blue lines, there would be a connection interval, right? So if you wouldn't have a subrate factor, it means that at each of these lines, the devices would communicate, regardless whether there's any data to be exchanged or not. If you use a subrate factor different than 1, then only every subrated event will be used. So in this case, the subrate factor is 5, so every 5th connection interval will be an effective one, used by both the central and the peripheral, and every other connection interval in between will be skipped. So they won't even turn on their radios to communicate, which allows you to save power. And the thing is that the subrate factor can be changed on the fly without changing the connection parameters. So if all of a sudden you want to go from 5 to 1 or 20 or a number, you can just update that, and they will immediately start following that, and skipping the connection events following the new subrate factor configuration. But then let's say that you want to have both low power and low latency. In that case, there is another configuration that can be used, which is called the continuation number. So what the continuation number means is that when you have the subrated connection interval, if the devices exchange a zero length link layer PDU, then they will skip the next connection intervals until the next subrated event. But if they exchange a non-zero length link layer PDU, The continuation number indicates how many connection intervals it will extend before they stop communicating. So in the event number 5 here, they exchange data. So there was a non-zero length PDU. So they will exchange it. And then the same thing happened on number 6. So they will increase it again. And the same thing happened on number 7 until reach number 8. So on number 8, again, we had a zero length link layer PDU. So then that means that the next one, now it will be skipped because we didn't exchange any data. So then number 9 will be skipped, and they sort of resynchronize again, if you will, at number 10, which is a subrated event, so an effective connection interval. And yeah, so I'll show you now how that works in practice with the nRF54L15DK together with the subrate factor, connection subrating sample from the SDK. So let's go and hop over to the demo. So, and for the demo, I'll be using then 2 kits. One will be operating as a central, and one will be operating as a peripheral. The central will connect directly to the PC using USB, and that I will be interacting with that sample using the serial terminal application in nRF Connect for desktop. And the peripheral device will be powered by the Power Profiler Kit 2. So it will not be connected directly to the computer. So we won't see the serial output from that, also because that will be disabled in the sample. And then using the Power Profiler Kit 2, we'll be able to observe the power consumption from that kit. And we'll be able to see what's happening and sort of map that out to the log and see what subrating factors are being used and how they impact the communication between these devices. Okay, so let's now go on and see how this works in practice. Okay, so let's get started with our demo. And first, I just wanted to go quickly through the documentation for the sample. You can find it very easily in the table of contents. If you go to samples, expand, then Bluetooth samples, expand, and you'll find that towards the end of the list over here. So at the top, we have the requirements table, essentially indicating which hardware kits you can use to run the sample. So we'll be using 2 nRF54L15DKs, an overview section, building and running, and then the most important part for this demo is the testing. So one of the kits will be running as the central, so that will be connected to the serial terminal application in nRF Connect for desktop. And the way we indicate to the kit that it needs to operate as a central is to just send a C over the serial terminal. Then we'll have the other kit operating as peripheral. This one will be connected to the PPK2, so it doesn't have a serial COM port available. So I made a small modification to the sample to force peripheral operation, and I also disabled the serial terminal so that we have a lower baseline current on the power profiler. So the samples in the SDK, or most of the samples in the SDK, are not power optimized, so that you have serial enabled by default to get all the application messages. So if you want to observe the lowest power consumption, you need to disable serial as the first step in the optimization. So what the samples do, or like the functional behavior, is that they will alternate between 3 different subrating configurations. So the first one is no subrating, or effectively it's subrating with a factor of 1. Then it's subrating with a factor of 10 and continuation number 0. And then it's subrating with a factor of 10, continuation number 1. So they will loop through these continuously. And then we'll be observing the output from the central device. So each time that the subrate parameters change, we'll have that printed out on the terminal. Okay, so let's go to our tools now. So on the right-hand side, I have the serial terminal application connected to the nRF54L15DK, or one of them. So I'm just going to go ahead and press reset so we get the boot message. And now this is waiting for either a C or a B to be sent so that we choose the device role, so how it operates. And on the left-hand side, we have the power profiler connected to the other kit, which is running a slightly modified sample with hard-coded peripheral operation. So we've already enabled power output, so we can start sampling. And what we can observe here is that this device, it's a peripheral, so it's advertising, and it's waiting for a central to connect. So we can go here on the right-hand side and send C. So it starts operating as a central, and immediately they find each other, they connect to each other, they do the service discovery, and then they start going through this subrating parameter loop. Yeah, so we see that things are changing a little bit when they connected. And if you observe here on the right-hand side, actually, if you look at the trace, maybe with a wider zoom angle, you can see that there's sort of a pattern coming here. So I'm just going to disconnect from the port and stop sampling so we can understand what's happening. So let's go all the way to the beginning. So this first portion here, this was the advertisement. So this is not interesting for this demo. But then we have sort of three, what appears to be sort of three different sections here. Each one of those will map to the different subrating configuration. So the first one is, actually, let's go to the second part, because here we have the connection establishment part. We can go here. This one is much more clear. So the first one is this one over here. So this is mapping out to the first subrating parameter configuration, the one here at the top. Subrate factor 1, continuation number 0. So what this means is that each connection interval is an effective connection interval. And the connection interval, in this case, it was in the documentation, I just forgot to highlight it, it's 10 milliseconds. So if we zoom in and we measure the time between these, we'll see that it's 10 milliseconds. So here, each connection interval is an effective connection interval. So if you have the need for low latency operation, this would be a potential configuration you could use. So the second part is this one here in the middle. So now we see that the space between connection intervals is wider, and that is the second configuration. So this is subrate factor 10, continuation number 0. So subrate factor 10 means that every 10th connection interval is an effective connection interval, and the ones in between are skipped because we also have continuation number 0. So if we zoom in and we take two of these and we measure, we'll see that it's about 100 milliseconds. So 10 times 10 milliseconds every 10th. So that adds up to 100 milliseconds. And then we have a third, which actually seems to have kind of both low latency and low power operation. So this one over here. And that is the third configuration, which is subrate factor 10, continuation number 1. So what does that mean? That means that, so another thing that the sample is doing is that it's also sending bursts of data with each of these configurations to measure the round trip latency. So if you remember from the explanation, from the overview, if you use continuation number different than 0, basically it means that if there's a non-empty link layer PDU, then it can extend. So it can use more connection intervals than just waiting for the next effective connection interval. And since we're sending these small bursts of data, in this third configuration, we can see that they're actually using more connection intervals. So if we measure the time between these, this is going to be 10 milliseconds. So to send that first initial burst of data. And then when we don't have any more data to send, so when we have empty link layer PDUs, then without changing the subrating configuration, even having continuation number 1, we go to a low power mode where only the 10th connection interval is used. So now we see that we have, again, 100 millisecond interval between each connection. So this is sort of like a best of both worlds configuration in a way, where you can have both low latency. So if you do have data that you want to send, you can send it very quickly. But as soon as you don't have any data to send, then it will immediately not use the continuation number because there's no data to be exchanged, and therefore you can go to a low power operation much faster. Okay, so yeah, so the sample is in the SDK. Grab yourself a PPK2 and experiment. It's a very useful sample. It really allows you to optimize your applications and much better balance between low power and low latency needs that you might have. Okay, so let's continue with the webinar. Okay, now for Matter and Thread updates. So starting with Thread on nRF Connect SDK 2.8, we added Thread 1.4 as supported. So what this brings, some of the highlights, is thread credential sharing. So what this means is that before this feature, when you wanted to commission new devices, very often you would create a new thread network, which is really inconvenient. So with this thread credential sharing feature, you can avoid that. So because you have the ability to provide sort of temporary access to credentials, and then you have devices added to existing thread networks instead of creating new ones. Also enhanced internet connectivity. So this can improve the connection to public internet on both IPv4 and IPv6. thread over infrastructure. So this means that traffic can be routed through IP-based networks in addition to the 802.15.4 radio. So the traffic that would go to thread devices, for example, on 15.4 can be routed using IP-based networks. So you could use Wi-Fi to route traffic so that it gets faster to that 802.15.4 radio device. And the last one is secure commissioning at scale with TCAT. So TCAT stands for Thread Commissioning over Authenticated TLS. So this is more towards the professional and commercial market for installing things faster in a larger scale. And this was actually covered in nRF Connect SDK 2.6 webinar, where this feature was added as experimental at that time. So if you're interested, I recommend that you go out and check that one. If you want to read more about these features, and it's also some of the smaller improvements, I have a link here to the Thread Group's white paper, so you can go and check that out. On Matter, in nRF Connect SDK 2.9, we added Matter 1.4. Just a coincidence that both Matter and Thread, both of the latest releases have the same number, but they are not sort of coupled together, let's say. So Matter 1.4 brings support something called ICD long idle time. So ICD is intermittently connected device with check-in protocol, user active mode trigger, and dynamic sit-lit switching. Sit is short idle time. So you can switch between a short idle time and long idle time. And we'll show you a short demo of this in a few minutes. Also, new energy management device types, so solar panels, batteries, heat pumps, and water heaters. Improvements in occupancy sensing, so it now supports new features like radar vision and ambient sensing. Also, enhanced multi-admin with fabric synchronization. So this is when you have the same device added to different ecosystems like Apple ecosystem, Google, Amazon, and so on. There's also a new sample, Matter Smoke CO Alarm. So, it has a specific functionality that it's demonstrating, but it can also be used to showcase long idle time and dynamic short idle time, long idle time switching. So DSLS for short, which we'll show in the demo in a bit. There's also a press release from the CSA about Matter 1.4. You can read more about these features and some of the smaller ones as well. So, just starting to introduce them a little bit here. So what is a Matter intermittently connected devices? So these are devices that only connect when they need to, basically. So, and there's something called a sit device, short idle time. So these are devices that sleep for less than 15 seconds. They typically only sleep for a few seconds, but they can do it up to 15. So, and that means that they're very responsive. So the controller, in principle, can reach those devices anytime. And the typical use case for a sit device would be an actuator, like for example, a door lock, right? If you want to unlock the door, you don't want to wait for too long, right? Which means that the Matter controller needs to reach the door lock and unlock it, basically as quickly as possible. And then you have the long idle time devices. So these are devices that sleep for more than 15 seconds. I mean, that's the sort of the lower limit. They can sleep, up to dozens of hours. These are not responsive to the control. They're only responsive after sending a notification to the control that now I can react to whatever the controller wants to communicate to the device. And they also support user action mode trigger. So user action means that the user will actually do something to trigger this device to be responsive. It could be a button press. It could be covering it, whatever. So these are more typically used in sensor use cases where you only need to send data very seldomly, like for example, this smoke CO alarm. And then you have this dynamic sit-lit switching, DSLS. This is an optional feature, and you can switch between these two modes as needed. So for the demo, we're going to demonstrate the Matter intermittently connected device sit and lit. We're going to be using the nRF54L15 DK as our hardware platform. For sit, we're going to use the Matter door lock sample. For lit and for the switching, we're going to use the smoke CO alarm sample. And then we'll have the Power Profiler Kit 2 sampling the power consumption. And things that we have in the Matter setup will be a thread border router that's already up and running, and a chip tool running on a computer as a Matter controller also up and running. So this is a demo that our Matter team prepared for us. So let's go and check it out before we continue with the webinar.
The nRF Connect SDK 2.9.0 provides production support for the Matter 1.4 and Matter intermittently connected devices, so-called ICDs. Today I'm going to present two different types of ICDs based on Matter samples. I'm going to use the nRF54L15 as a platform and Power Profiler Kit 2 as a tool for capturing the current measurements. I have Matter door lock sample flashed and running. As you can see, these periodic peaks that mean the device is advertising over Bluetooth LE. So the Matter ICDs can operate in one of the two modes that are called short idle time SIT and long idle time LIT. SIT device typically sleeps for single seconds, so it's generally responsive and can be reached asynchronously. I'm starting the device commissioning with chip tool using the pairing BLE thread command with thread network datasets and device data I've obtained before. And it's done. Now we can see that there are periodic peaks with 1 second interval. Yeah, these are thread data pools as the device is configured to use ICD slow pooling equal to 1 second, and now it is in the idle state. Let's try it, for example, unlock the door using the door lock unlock door command. Yep, and it worked very fast as the device is very responsive. Here you can see some wider peaks that are related to the data transmission, and they appear with 200 milliseconds interval. This smaller interval is called fast pooling, and ICD uses it in the active state to exchange the data faster and get back to the idle state. To sum up, the SIT device usually is pretty responsive, so this is perfect fit for the actuator, which is door lock in our case. Now I'm going to do the same for the smoke CO alarm sample. This is long idle time device. It sleeps much longer than SIT. It can be dozens of hours, but in our case, it's 30 seconds from the practical reasons. It's not responsive and controller cannot control it without prior notification. And this is typical configuration for sensor-like device. Yeah, so I'm also going to commission it using the same command, so pairing BLE thread. Thread dataset. Yeah, but it's important to add additional parameter at the end, which is ICD registration through flag. You may be surprised that after commissioning, the pooling interval will not be 30 but 5 seconds. The reason is that our sample supports optional feature called dynamic sit to lit switching that allows us to sort of force the device to be sit, even though it could be lit. And it's done. Now we can see the periodic peaks with interval of 5 seconds. So device acts as a sit. For example, it could be that our sensor is powered from the wired source, so we don't care about the energy and it can be sit. But in case of power outage, it should switch to lit and use battery power. So I can emulate power outage using a dedicated command that is general diagnostics test event trigger. Yeah, this is the default key for the test event trigger and the event ID for the endpoint 0. This command disables the wired power source on the device endpoint. First, you can see a big group of peaks with small interval that is command reception plus 5 seconds active mode threshold after that. And now we need to wait a bit for the data pool. Let's zoom it out a little bit. And finally, you can see that the device changed the interval. So now it works as a lead, and it's 30 seconds. Yeah, lead also supports additional user active trigger mode feature that allows to make device immediately responsive, for example, using the button press. So now I'm pressing the button 3 on the decay, and you can see that the interval was changed into smaller one, so the device is responsive and can be, for example, easily reconfigured. And that's it for this demo. Thanks for watching.
Okay, that was a really great demo. So moving on to Wi-Fi. Let's see. Okay, so on nRF Connect 2.8, we added offloaded raw transmit beaconing. So this basically simplifies a little bit the host application firmware because you can do the beaconing. It allows the beaconing to be done autonomously on the nRF 70 series companion device instead of being triggered by the host. We also added an experimental enterprise mode for station, EAP TLS, so which means that you can now use the nRF 70 series companion IC to connect to Wi-Fi enterprise installations. Still on SDK 2.8, we added a couple of improvements in when it comes to connection stability and interoperability with the different access points. And also, we did some power consumption improvements on the boot up current for the nRF 70 series devices when you have a passive scanning use case. That means that when you have passive scanning, you're not using TX, so you can skip the TX calibration at boot, which means that the boot current can drops from approximately 270 milliamps down to 80 milliamps. And last thing on Wi-Fi, in nRF Connect SDK 2.9.0, we added WPA3 Enterprise Security to the nRF Wi-Fi driver. So you can use a host like the nRF 5340 SoC to implement WPA3. This is using the legacy crypto API, so the non-PSA APIs to implement this feature. Okay, so moving on to the last and final topic, which is Cellular IoT, Cloud, and NR+. So on nRF Connect SDK 2.8, we added support for the Thingy 91X. So this is our newest cellular IoT prototyping platform. This is based on the also very new nRF 9151 system in package, but it includes more Nordic parts. It also includes the nRF 7002 Wi-Fi companion IC for Wi-Fi locationing and a few other pieces, a few other bits and pieces that I'll show you on the next slide. As experimental in nRF Connect SDK 2.8.0, we added a new sample for NR+, the DECT NR+ shell. So this can show you how you set up a DECT NR+ application, and you can do some testing around different modem features and the performance. And just a reminder that if you want to get access to the DECT NR+ PHY modem firmware, you need to contact our sales, and they will be able to give that, provide that to you. On nRF Cloud side, experimental nRF Cloud SMP FOTA. So that means that you can update the companion device, like nRF 52 series device or even nRF 54 series device, running MCU boot from you. So you receive the photo image through the cellular device. So there will be a device on the nRF 91 series from the cloud, from nRF Cloud, and then you can use that to update a companion device outside of the nRF 91 series. And there's a sample to showcase that, the nRF Cloud REST FOTA sample. Yep, so the Thingy 91X prototyping platform. So this supports LTM, NB-IoT, GNSS, DECT NR+, and Wi-Fi locationing. So it contains 5 Nordic devices. nRF 9151 is the centerpiece of this prototyping platform. Then we have the nRF 7002 Wi-Fi device for Wi-Fi scanning, Wi-Fi locationing. nRF 5340 acting mostly as a board controller. And then we have 2 of our PMICs, the NPM 6001 and the NPM 1300. That provides you, amongst other things, battery charging and fuel gauging. So it also has onboard sensors, a rechargeable battery. So it's great if you want to take it out in the field for testing. User programmable buttons and LEDs. You have an expansion board with a quick compatible connector. So quick Stemma, StemmaCute, and a few other ecosystems. One really cool thing about this device is the out-of-box experience. So as soon as you get it you can just insert the SIM card, scan the QR code, and you'll be able to immediately start interacting with your device. So if you want to check that out, I recommend that you check the launch video that we have on YouTube, and it will show you how simply it is to get started. So this prototyping platform is really great for asset tracking applications because you can do cellular-based locationing, GNSS, as well as Wi-Fi-based locationing. So it gives you a sort of a good mix of capabilities to balance between power consumption and accuracy for asset tracking applications. And for connectivity, it's bundled with preloaded SIM cards, so you don't even need to worry about the connectivity piece. You just use one of the SIM cards, and you're going to be up and running in a few seconds. And the last thing before we move on to the Q&A is nRF Cloud. So one feature I'd like to highlight on nRF Cloud is the message routing service that was GA'd a few months ago. And why is this important? Well, actually, maybe starting to explaining what it is. So essentially, it will allow applications to automatically push data via nRF Cloud into your application service. And why is this important in the context of the SDK? Because this means that if you have a cellular application that is connected to the cloud, you can essentially streamline your cloud connectivity using nRF Cloud as a unified endpoint. So instead of the device here, talking to nRF Cloud for, let's say, locationing, for sending the location data or for device management, and then separately sending the data, the actual application data to the application service, you can do that everything through nRF Cloud. So what that means is that your firmware development will be simpler because you only need to talk to one cloud endpoint. And sort of expanding on that, it means that your maintenance or your firmware maintenance costs will be lower, which will lead to higher stability and robustness of the firmware, which in turn will lead to you requiring fewer photo updates, which will also give you power consumption benefits, giving you lower power, longer battery life. Also using the nRF Cloud co-app interface, which is another thing that's really relevant here because nRF Cloud supports co-app. Then you have also the library, the co-app libraries on the nRF Connect SDK. So you can use that to have a lower power protocol to send data to the cloud. Because often the application clouds do not support co-app. So you'd be using co-app for nRF Cloud and then something like MQTT to talk to the application service. So you'll have a sort of not very power optimized implementation. So yeah, really recommend that to check that out if you're in the cellular IoT space and sending data out to the cloud. All right. So we've reached the end of the webinar. So really recommend that you guys sign up for more webinars at webinars.nordicsemi.com. Again, check out our courses on the Dev Academy. If you're a developer using Nordic solutions at academy.nordicsemi.com. If you're in need of tech support, that would mean you should head out to the DevZone at devzone.nordicsemi.com. And for general information about Nordic's products and services, you should visit nordicsemi.com. And let's move on to the Q&A and start taking some of the questions that came during the webinar. All right, thanks for all the questions that came in. We have quite a few, so let's get going. So the first one: when will the examples be updated for 2.9 in the Dev Academy? So actually, some of the courses are already updated. The fundamentals, so the nRF Connect SDK fundamentals course, Bluetooth LE fundamentals and cellular fundamentals are already updated, and we're currently working on updating the Wi-Fi and the nRF Connect intermediate course. Don't have a specific date when that will be ready, but the answer is that we're working on those. Okay, the next question: are both the nRF 7002 and the nRF 21540 FEM supported in the nRF 54 series? So the 7002 supported experimental maturity on the nRF 54 L15 only. Not on the L10 or L05. When it comes to the FEM, the support will come on a later SDK release for the 54 L series. Okay. Next question: when do you plan to have photo DFU tools from nRF SDK to nRF Connect SDK? So I think the question is from nRF 5 SDK to nRF Connect SDK. Actually, we're working on one at the moment. I don't have a specific date when it will be available, but it's being worked on right now. Then to program the nRF 54L15 SoC, what interface is recommended? So I'm assuming you're talking about a custom design where you don't have onboard debugger. So in the case, you will need to have the SWD pins exposed, and then use an external debug interface to program it, to program the part on your custom board. Then a question about Zephyr 4.0. So, well, broadly speaking, it will come on a later SDK release. I don't have a specific date. It's more of a roadmap question. But of course, we try to always take the latest Zephyr versions when updating the nRF Connect SDK. So you should expect to have that on one of the next SDK releases from our side. Okay, another one. Will the MCU boot compression be supported for the nRF52832 device? No, it won't be supported. So the parts that I had on the slide, the ones that are supported, those are really the only parts that are supported for the MCU boot compression. And the reason is actually lack of RAM to support that feature on the smaller parts. So unfortunately, it's not supported on some of the smaller parts. Then question about AND. Actually, there are two questions about AND. I think there's one in the chat as well. So when it comes to AND, this is maintained and essentially managed by Garmin. They update it when they want to update it. To be honest, we don't really control that. So if you have any questions on ANDs and when they will update that to 2.8 or 2.9, that's something you would need to go to Garmin. I'm not sure if they have a public forum or what their contact form is, but this answer needs to come from Garmin. And there were the other one in the chat that I saw. I'm not sure if it came to the questions list, but it was about support in nRF54L15. So the same thing applies there. You need to ask from Garmin. Okay, let me see. I kind of lost track of the questions here. Oh yeah, okay. So about the add-ons. Does nRF Connect SDK add-ons have different license policy from nRF Connect SDK? Yes, they can have. So depending who they come from a third-party vendor, they can have a different license. So that's one of the reasons why the add-ons are there, to allow them to release software, make it available to work together with nRF Connect SDK. And whether they can charge money or not, that could be part of the license. So indeed, that's an option for third parties that want to contribute to the sort of wider nRF Connect SDK ecosystem through the add-ons. Another question. Just mark this one here. Answered. Yeah, just one thing about the add-ons. Let me highlight the previous question. Is that if there's a different license, so each add-on has to have its own repository. So you should find that license txt file in the code repository. So then you will know that there's a different license than the one that the nRF Connect SDK has. Okay, I'm looking to update an app to the latest SDK. I'm not clear whether Sysbuild is a recommended approach for production use with bootloaders, partitions, etc. Yes, it is. Now, though, Sysbuild is the way forward. I talked about Sysbuild on the 2.7 webinar, so I recommend that you check that one out. And of course, if you have any questions, there's extensive documentation about Sysbuild in the nRF Connect SDK documentation. And also, you can also go to DevZone if you're having any issues getting up and running with that. Okay, next one. So asking the question is, what BLE features are available for the nRF52840 with the SDK 2.8 and 2.9? Is Bluetooth subrating applicable? I believe it is, but there's a table. Let me copy that table to the chat. Just 1 second. Here we go. So there's you can find it on the release notes section. There's a software maturity table where you can find, it's on the chat now, and you can find a table with all the Bluetooth features and how they are supported across the different devices. Okay, let's scroll down a little bit. Okay, oh yes, this one. Thread 1.4 has enhanced connectivity on IPv4. I thought Thread is using IPv6 only. Well, that is correct, but this is not just about the Thread device. This is about connectivity to the wider internet, and there's still many, home networks, infrastructure, internet servers relying on IPv4. So this is about translation between IPv4 and IPv6 on the border router side of things. So that's where the enhancement is. It's not on the Thread device itself. But if you want to read more about this, I really recommend that check out the white paper. If you just go to Google and type thread 1.4 white paper, that should be the first result, and then you have a little bit more detail on what that means from the thread group white paper. Okay, then still one on Matter. Leak sensor uses lit, so long idle time. I'm not actually sure. That's something you could check from the specification, whether lit or SIT is used. But the main use case for lit is sensors, broadly speaking. So I would assume that a leak sensor would be able to use lit. At least that I don't see any reason why it shouldn't be able to use it. Okay, this is actually an interesting question. Maybe this is something I could start adding to the webinars at the beginning. So what does it mean when a feature added is experimental to the SDK? We actually have a definition for this, and let me paste that into the chat as well, the link. So here it goes. So there's a table with the software maturity classifications. So not supported, experimental, and supported, and what that means in practice. So you can check that out. So, but essentially experimental means that it hasn't been fully verified. There might be changes in the API, and also we might choose to remove it. So there's no guarantee that whatever features is classified as experimental that will be bumped to support it. We might just also remove it if for some reason turns out that the feature is not what we need or not the way that customers were going to use it. So that's also something that customers need to be sort of aware of when using experimental features. Okay, next one. Is it planned to use certificate-based authentication and pairing? I think this is for Bluetooth Mesh, and this is a roadmap question, so I don't really have the answer to this one. Next one, are there any plans to work on audio over Wi-Fi or Ethernet? Again, roadmap, can't really comment on this, unfortunately. And yet another one that falls into the roadmap category. I looked into documentation. Definitely, we don't have this. It doesn't seem like we have this today. But I mean, this is a GATT service, as I understand it. So that means that customers can also implement it on their own because you get the specification from the Bluetooth Bluetooth spec. But we don't have it today in the SDK, as far as I'm aware, at least. Yeah, and I already answered this one, and on the 54L15. So the answer is that you need to go and check with Garmin what the status is over there. Okay, there's one question that came. I can still take that. Might have understood this TCAT from thread now left. Yes, it was introduced as experimental. I covered it on 2.6 webinar, so you can check that. But now the whole thread 1.4 is supported, including this feature is also now supported. So it's not experimental anymore. Okay, let me just check if there's anything on the chat that I could also. Do you have any plan for supporting iSIM? So we don't have iSIM support on the nRF 91 series devices. So today we don't support it. Beyond 91 series, it's a roadmap question, so I can't really comment on that. Where do I find examples for channel sounding? I can. So they are on the link from the slide. Let me see if I can quickly find those samples and put the links there. The samples. Yeah, I'll just quickly put the links on the chat as well. So this is for the initiator, and put it for the reflector as well. But again, just mentioned, just like mentioned during the webinar, keep in mind that these are mostly to demonstrate how the data is exchanged, and the result that you get for the ranging is not representative for what channel sounding can actually do. So that's something that we're still working on making the algorithm, giving you a true representation of distance measurement. Okay, I think we ran out of questions. So we had quite a few. So thanks for participating. Thanks for asking questions, and have a good day. Have a rest of a good day, and hope to see you on the next webinar. Thank you. Yeah, so let's get going. There's a few questions that came in. Go to the question tab here. Okay, first question just showed up so everyone can see. When will support be added for debugging the nRF 54 series to nRF Connect extension in VS Code? Well, it's already there for 54L series. I'm not sure about H because that's in sampling. But there should be no issues with debugging nRF54L. And then question about channel sounding. Yeah, with channel sounding enabled now in SDK 2.9, does this mean we can utilize multiple antennas for measurements? It's a good question. I mean, the kconfig is there. I'm not sure if the functionality is supported. Need to check the documentation if it's there. And then will channel sounding be merged with nRF distance measurement toolbox? No, so these will be different solutions, and also they will be supported across different device series. So the NDT, so the acronym for Nordic distance toolbox, that will be supported on nRF 52 series and nRF 5340. And channel sounding will only be supported on the nRF 54 series. And these are separate solutions. They're not going to be merged. And also the mechanisms, how they measure the distance are a little bit different. One more question. I just received my nRF 52840 board. Is there someone who can help with Zephyr support? So the recommendation is that you go to the Developer Academy and start with the nRF Connect SDK fundamentals course, and then take it from there. If you have any issues or things are unclear, there's feedback, possibility to provide feedback within the course itself. You can also take notes, and you also have the dev zone if you get stuck somewhere and you need a little bit more support. Our tech support team and dev zone will be happy to assist you with that. Another one on DevZone. I actually went to check that out because I wasn't sure if this had been updated already. So we started a project with 2.8, but the DFU photo section on Nordic Developer Academy is still empty. So this is on the nRF Connect SDK Intermediate course. When will the documentation be finished for this section? Now, I don't have a date for you. It's being worked on at the moment, but I think we're talking about weeks and not months to have this updated. So we'll always try to keep the courses updated. But the changes introduced in the past few SDK versions were more significant than before, so it's taking a little bit longer to get the courses updated for these more recent SDK updates. Next one is there a way to get access to the old distance measurement toolbox algorithm for channel sounding? They won't work with channel sounding, so the data sets are different. So today we don't. Yeah, so the algorithm that is there is just for illustrative purposes, as mentioned during the webinar. So we need to wait for us to provide the actual ranging algorithm, which will come on a later SDK. Otherwise, you can create your own. I don't really have. I know that the Bluetooth SIG has some technical documentation on how this could be done, but that has not been tested by us, so I cannot say whether it's a good solution or not. So I guess just checking for information out on the internet if there's anything that could be used. But my recommendation is that you wait for a solution from Nordic in one of the upcoming SDK releases. One about ESL. So will the ESL example be ported over to the nRF54L15, or are they considered abandoned as they're part of the Nordic playground, not the I'm sorry, not the main organization? I'm not sure whether, I mean, I think it makes a lot of sense to port this over to the 54L15. If you're doing a ESL application, that would be probably the most suitable device for that. I know it's on the playground, it's not on the SDK, but just because it's on the playground, it doesn't mean that it's not going to be maintained to some degree. But I don't have the answer whether this particular example will be updated or not. So I might try to get this answer and reach out separately by email if I can get that information internally. Sorry that I can't provide it right now. Next one, a few more that came in. I'll take those as well. Whoops, not there. There. Is Bluetooth LE connection subrating also available on the nRF 5340? Yeah, it's actually, I want to check I'll put the link. Put the link on the chat. So in the releases and maturity section of the technical documentation, if you expand that, there's a software maturity level section there. And if you scroll, you'll see multiple sections for each of the wireless protocols. And one of them is for Bluetooth. And there you can see different features. And then you have that on all the lines, and on the columns you have all the parts. Then you can see what's supported on the different parts. Also, whether it's supported or experimental. In this case, subrating is supported for nRF 5340. So I went to check that from the table that I just linked in the chat. Another one. Can the RISC-V core be debugged individually on the nRF 54 series? I believe the answer is yes, but I'm not 100% sure. So I would recommend that you go ask on DevZone if this is the case, because I think so, but I don't want to give you wrong information. So really, recommendation is to go to DevZone. Is there any example demos that use a device's AD converter to send out data? Good question. There must be examples for the ADC. I, of course, don't know all the samples on the top of my head. Just a matter of checking the SDK. We also have, by the way, we have a Ask AI widget, which you can access from DevZone and TikTok. So you can also ask there and on DevZone if they can, if there's any specific example that could, sort of showcase what you're looking to learn more about. And then when will debugging for H20 be supporting VS Code? I don't have. This is more of a roadmap question, so I don't actually know the answer to this one, since the H20 is still in the sampling phase. Okay, I think this might be the last question if no more questions come in. Embedded Rust is making good progress and is looking like a good memory-safe option for my controllers. Is Nordic planning to support this language more, or possibly support it working with the nRF Connect SDK? Yeah, so there's been quite a lot of say noise about Rust. I know that Zephyr project is looking into Rust, but I'm not sure how far they are with that. So if Zephyr adopts Rust in some shape or form, that would mean that the nRF Connect SDK would get the same level of support as we incorporate Zephyr in our SDK. But beyond that, it's more of a roadmap question. I'm not aware that we are actively going after this, but with progress being made on Zephyr, and if there's traction, if there's customers looking at using Rust more, then that's something we would, of course, be following and potentially doing some work around. But for now, this is a roadmap. Okay, it seems that there's no more questions. I saw something in the chat, but I'm just wondering. Okay, so these were. This was added to the questions. I saw a comment about Rust. Yeah, I know that the Linux kernel is also, or has incorporated some level of Rust, but I'm not very familiar what was actually done there. Okay, so if we don't have any more questions, I'd like to thank everyone who joined today. Thanks for attending. Thanks for the questions. And yeah, have a good day, and hope to see you for our next webinar. Thank you.